solving trig equations with exact value solutions. So we've actually already done some solving equations, right? So when you have something like sine theta equals root 2 over 2, that's an equation that we already asked you to solve, right? So this would be pi over 4 or 8 pi over 4 or multiples of those. Those are pretty basic. This, what we're doing today, is a little bit more challenging. Maybe you have to do some factoring, maybe a rearranging of the equation and then some factoring, okay? We've also done solving equations already with a calculator, guys at the back. So this is just an extension. We kind of have a little gap in there to do identities because before we're done this unit, we'll need to use some identities in some equations as well. But just realize this isn't something brand new. We have been doing it so far. Okay, so a trig equation contains a trig function or more than one. Some trig equations are given there. So 2 sine theta plus 4 equals 3, you would solve for sine theta and then find theta. This, we've got a cos squared cos and a constant term. Cotan squared, a constant. Sine and cosecant. Okay? So we could solve all of these using our calculator, but remember our calculator does not give us the exact value. So it'll give the decimal form, and if it's a rational decimal, then you could match that and get it. But if it's an irrational decimal, the calculator won't do that. So we need to be able to come up with exact values. So previously you solved trig equations graphically. Some examples, we did this. That was graphed on a graph in our notes. Okay, and in this case, graphically, we could take the left side of the equation, the right side of the equation, and find the theta coordinates of the points of intersection. Or you could get all the terms on one side, put it into y1. Right side is 0, so graph y equals 0, and find the theta intercepts. Okay? In any case, we can do that graphically. It's, as I just mentioned before, it's not always possible to determine an exact value on your calculator. So we're going to work through that today. It says since trig functions are periodic, there may be infinitely many, right? It's cyclic. So there might be infinitely many solutions for a trig equation. So we're going to, in some cases, need to give the general solution, not just for a certain interval. So unless the domain for the solutions to the equation is restricted, a statement regarding the general solutions, for the equation is required. Okay, and that's very similar to what we've been doing for asymptotes, restrictions, so it's not going to be too difficult in that sense. Okay, so question number 1. These are not equations in question number 1. They're trig expressions, and all it says to do is factor. Okay, so factoring, you look for a common factor. Oh, sorry. Yours does not have. Mine is. So yours says factor, and there should be expressions. And you don't have this. Okay. So look for a common factor. In the first one, there's a sine theta in both terms. Factor it out. like solving polynomial functions or polynomial equations, we had to factor first. Okay? Sometimes we had to use synthetic division, right, to get it down to factors as small as possible. Sometimes from there we had to use the quadratic formula if we couldn't factor, right? If this was equal to 0, then we would let each factor equal 0. Okay? Just like in polynomial. But in any case, you're just asked to factor these expressions. Take a look at this. Cos squared, cos, and constant. So if I gave you 2a squared minus 7a plus 3, so back to math 10, how do you factor that? So factor that. All that's different is instead of a, it's cos of theta. So if you need to do that substitution to help you out, do it. So there, where a equals cos theta. So two numbers that multiply to 6, add to negative 7. So that's going to be negative 3 and negative 1. Guaranteed that you're going to have to factor. Okay, so 4 times S. Last one, 2 terms. Okay, what do you notice about the first term? What's special about it? Perfect square. Okay, so what's the last term? It's a difference of squares, which factors to conjugates. So that's going to be 2 sine x plus 1, 2 sine x minus 1. Okay. Again, if you wanted to say, oh, let's show that as 4a squared minus 1, where a equals sine of x, you're welcome to do that. Okay, but hopefully you can get to the point where you can see it's a difference in squares. So that's just practicing factoring. Question 2 says algebraically solve for the indicated domain. So we're restricting the domain, which basically says you only have to give solutions within that. You don't want a general solution. Okay. So first one, we solved this back in the notes there, but in any case, there's your equation. If you just have one trig ratio in it, just isolate it. It's not squared, okay? It's not multiplied by anything else. There's just one trig ratio. So 2 sine theta equals negative 1. So sine theta equals negative 1/2. So this is where your unit circle has to come in. So where is sine negative? So 3rd and 4th quadrants. Okay. Reference angle would be from sine theta equaling positive 1/2. Okay, so sine is the y value, so that's 1/2 is the smaller. So that's going to have a reference angle of pi over 6. Remember, we're dealing in radians, so it's going to be there and there. Okay. So this is pi over 6, the reference. So that means theta equals, so from the initial arm to the terminal arm would be pi plus pi over 6, which is 7 pi over 6. and then 2 pi minus pi over 6, which is 11 pi over 6. Okay? Because theta has to be between 0 and 2 pi, so we just need one positive rotation.
How about we learn radians? I hate working with degrees. Is it just me? I agree so much. Well, then no, I love exact values are way better than decimals.
Okay, so if in your calculator you got to sine theta equals -1/2, then really, remember we did this using the positive value to get the reference. Say you forgot about it, right? So you just went, okay, so just let me check here. Yes, it is. So if I just go second sine -1 divided by 2, I get a negative angle, which doesn't fall into that, right? And it's a decimal. Okay? And it's not going to, well, I guess what you could do, like a math frac is not going to work. But if you think about, okay, radians, maybe if I divide by pi, it will help me get the fraction, right? So then you can go math, that's not what I want. Math frac. So then it's negative pi over 6, because I divided by pi. Well, negative pi over 6 is equivalent to positive 11 pi over 6. So then you have to convert that to a positive angle. So sometimes you can get away with using your calculator, but you actually have to know a lot to be able to use your calculator properly, because it doesn't give you every angle. So it's kind of better to just do a little sketch, figure out where your angles have to be, think about what the reference angle is, and then those angles in those quadrants. This gets a little bit confusing. You have to think through it a little bit more than really need to. Okay, so B, so in A, I isolated the trig ratio, and the other side was not 0. Okay? Kind of like a linear equation, back to solving in math 9 and math 10. Then, this one has a cos squared and a cos. That looks like a 0. It should be a theta. Yours is theta, so it's all good. Okay? But if you have those, then you need to get one side equal to 0. Do not just factor cos of theta then. You never do that with a quadratic, right? You never say, oh, 3x squared minus 6x equals 8. I'm going to factor out a 3x and let those equal. You never do that. So the same thing goes with this. It's quadratic, get one side equal to 0. And you'll notice in the work that you did above, you factored this one already. So look back at question 1 and show the factored form. Okay, so you already had the factored form, you already did that. Back in question 1, put it in here. Now, just like quadratics, each factor equals 0. Right? Now, each of those are linear equations in terms of trig. Okay, so we want to isolate cos theta equals 1/2. Here, cos theta equals 3. Right? Cos theta equals 3. Is that even possible? No, there is no angle that will satisfy that. So no solutions from that part. Okay? Cos theta equals a half. There are. So cos is positive in the first and fourth. We're dealing with degrees in this one. So look at what the domain is. It's degrees. Okay, folks, quiet please. So positive 1/2, first and fourth. Cos, that means 1/2 is the adjacent side, the x side. So it's going to be like that, or like this. Okay, so the shortest side is 1/2. And so that is a reference angle of 60 degrees. And 60 is in the first quadrant, so that's one of our angles. So theta equals 60 degrees, and 360 minus 60, which is 300 degrees. Notice how there's no denominators, there's no reciprocal trig functions, there's no restrictions to check against. It's simply solving each factor. Okay. Next one. Is it a difference of squares? No. Okay. So it's not a difference of squares. I mean, I guess you could take the root of 3 and that would work and do conjugates, but there's only one term with a trig ratio in it. So let's isolate it since we can't factor. Okay, so I bring the 1 over, divide by 3. Okay, then cotan squared equals 1/3. Let's get cotan by itself. So that means we take the root of both sides, plus or minus. That's the biggest thing students forget about. Root of 1 is 1. Root of 3 is root 3. You can rationalize it, but you're not done the question yet, so it's not mandatory. I'm going to leave it like that because this is a reciprocal trig ratio, cotan. It is the reciprocal of tan. So I like tan better in terms of thinking of my unit circle. Certainly if you were going to use your calculator at all, that's tan in there. So cotan is a reciprocal, so if I want to show this as tan x, this would be plus or minus root 3 over 1, which is root 3. Flip it. The whole thing. Right? Because it's just one term on both sides. You can't flip it. There's more than one term, but it's proportionate. It's basically a proportion. Okay? Now I can solve. This says I have to give the general solution. It says x is an element of a set of reals. It doesn't specify what unit of measure. So you could use degrees or radians in this one. Okay, I'm going to use radians just because it's usually something that you have to practice a little bit more. Okay, so this is really two equations. Tan x equals positive root 3. So tan is positive in first and third. Tan x is negative root 3, so second and fourth. This will cover all 4 quadrants if you have plus or minus. So really, we want to know what angle gives us a tan of root 3 to get that reference angle. Okay, so that comes from 30, 60, 90, or pi over 6, pi over 3, pi over 2 triangle, where the root 3 over 2 is the numerator, right? So the y value. So this needs to be root 3 over 2. This needs to be a half, because when you divide those, remember the 2's divide out. So this is pi over 3. So there, So pi over 3 is your reference angle. So your values, what I do if I'm doing the general is I do it for, I pretend that it's just for one rotation. This is just me personally. So I just do it for one rotation to start. So that's pi over 3, 2 pi over 3, then 4 pi over 3, and 5 pi over 3. That's for one rotation. Dot, dot, dot means it goes on forever, but that's not a proper general solution. You have to state it in terms of the angle plus multiples of the period. So sometimes students will look at this and will go, oh, it's just multiples of pi over 3. It's not quite, because if it's multiples of pi over 3, it would be that one, and this. And this one, and this one, and this. This does not include those horizontal. So this, basically, pi over 3 plus pi, the period, gives you this one. 2 pi over 3 plus pi gives you this one. Remember the period for pi, the period for tan is pi. So that's how we're going to show this in a more compact for the general solution. So x equals pi over 3 plus multiples of pi, 2 pi over 3 plus multiples of pi, where n is an integer. Again, that's why I like to do a little diagram, my unit circle, so that I know, even doing it in I did it all in one color. I do it better, maybe if I do it in green, then you can tell it doesn't include the horizontal axis. Okay. Okay, next one's kind of similar. You start on that one. B secant square theta minus 4. Again, it's not a difference of squares because they're at 3. So isolate the secant square. Okay, then take the root of both sides. And again, you can rationalize it, but take a look at it. It's secant. That's a reciprocal trig function. So I'm not going to rationalize it because I'm going to take the reciprocal, right? Flip that. That's a proportion. One term on both sides, so I can flip both of them. Okay, secant is 1 over cos. If I flip that, I get cos. Flip the right side, I get root 3 over 2. Because of the plus or minus, it's going to be in every quadrant. Okay? Cos is positive in the first and fourth, negative in the second and third. Then you have to think what reference angle gives you a cos of root 3 over 2. Root 3 over 2 is the longer of the two lengths in a pi over 6, pi over 3, and pi over 2 triangle. So, and it's got to be the horizontal. So that would be, so this is root 3 over 2, this is a half. This would be your pi over 6. Now, what did it say here? It said theta theta element of the set of rails, so you can use degrees or radians. Maybe we should use degrees just to switch it up. So that would be 30, 60, 90. So there, 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 there. Have a bow tie. Got it? Go do it in green. What's that?
The other one's a typewriter.
Yeah.
By the way, it's got time.
Oh, that's right. Okay, so this is, as I said, I'm going to use degrees here, 30. So, what else? Space up here. Okay, so I'm just going to go down here. So we're dealing with theta. Again, I like to do one rotation, then go to the general. So that's 30 degrees. This would be 150. 180 plus 30 is 210. 360 minus 30 is 330. Okay?
Can you also say, like, so I'm just looking at the other one, can you also say plus minus pi over 3 plus 1 pi? Would that also work?
You can do plus or minus, yeah. I just always stick to positive, but yeah, for sure you can do plus or minus. So here, again, you might think you can do equal intervals. 120 between that one and that one, but it's not 120 plus between that one and that one. So you also might think, oh, well, the period for cosine is 360 degrees. That would be if we're doing this one, going around and just getting that. Well, because of that plus or minus and having 4 within a complete rotation, it's going to cut it down, right? You don't have to do 4 separate statements. You can look at this. That ends up being plus 180. This is plus 180. So, to get the simplest statement, it's not going to necessarily be adding the period. You can, but we'd have to have 4 separate statements if you're adding the 360. Okay? So you can go 30 degrees plus 180 n, or 150 degrees plus 180 degrees n, if the n is if this was a multiple choice question, you need to realize that that might be how I stated. If you do it as 4 separate ones, you're going to have to check through those multiple choice and see which one corresponds to yours, right? We'll usually give you the simplest set. It's not wrong to do each angle plus multiples of 360, but it's not in simplest form. Okay. Okay, try 3A. You're just stating the solutions between 0 and 180, and then, okay, then state the general. So does one trig ratio, so that means we'll isolate secant theta to be -4 divided by 2, which is -2. And then show it as cos. Do you have to show it as cos? No. You know what secant is? And go for it. I just prefer, in my mind, to think about it as a primary trig ratio. negative 1/2. Where's cos negative? In the second and third. Okay, cos means that's your x value. Okay, on the unit circle. So negative 1/2. So that's going to be the shortest side. So it's going to be there and there. So the reference angle is, we're doing it in degrees. The reference angle is 60 degrees. So in this case, for the this given domain, there's only one answer, only one solution. X equals 120 degrees, right? Based on that. Okay. But for your general solution, you have to look at the whole rotation. Okay, so that would be 120. Okay, if I thought, okay, 120 to 240, so add 120. From this, if I add another 120, I don't get an angle on this. So I'm going to need two separate statements, 120 plus multiples of 360, and then 240 plus multiples of 360. For this one, right?
Based on
Yep, so there's two parts to this. So solve for the indicated domain and then state the general solution. There?
What that means is that the general one doesn't take it to the domain.
And E, isolate sine theta. There's only one type of trig ratio, it's sine. It's not squared. So again, isolate sine theta. Simplify the radicals. And then doing in radians, and two rotations worth of angles now. Negative rotation and the positive rotation. So where is sine negative? 3 and 4. And root 2 over 2, remember, is a reference angle of pi over 4. So if we think think about the negative rotation, that would be negative pi over 4 and negative 3 pi over 4. So I'm going to write those first, just from smallest to largest. Now positive rotation, that would be 5 pi over 4 and 7 pi over 4. And then general solution, theta equals, so I always use the first positive as my starting angle. So that's going to be 5 pi over 4. Plus, I've got to go a complete rotation. Just going to here isn't going to keep getting them through. Got it, Amanda? Okay, so that's going to be plus 2n pi, or 2 pi n. Then this one, remember, is 7 pi over 4 plus 2n pi. And then n is you can put those in squiggly brackets as well. Okay, turn over just a couple more questions. Again, going back to graphical solutions. A little bit hard to see with that photocopy. A little bit easier here. So look on the smartboard to see what that horizontal line is. A little bit hard to see. So it says write a trig equation such that the x-coordinates of the points of intersection are the solutions. So look back at the first question we did. We filled in, it wasn't even a question, it says, previously we solved 2 sine theta plus 4 equals 3 by going y1, guys, equals the left side and y2 equals the right side. So now you have 2 graphs. Left side will be one of those graphs, the right side will be the other graph. Good practice to come up with the equations of lines. It doesn't say you can use sine or cos. Which would be preferable? Cos, because the maximum is on the y-axis. So, look for the period. Period turns out to be 2 pi. So, b is 1. There's no equation to produce cos. So that's going to be my one equation. My second equation is y2 equals 4. Okay, so now when I'm solving this, I would use to solve the equation 2 cos x plus 5 equals 4. And then solve that. can check it on the graph. Right? It's basically going to be the same as this one, right? Except in radians. Okay, so solve it for negative 2 pi to positive 2 pi. This is negative here and here. 1 half. Okay, so that is pi over 3. Okay, so negative 2 pi would be negative pi plus pi over 3, so negative 4 pi over 3. Here, negative 2 pi over 3. Then positive would be positive 2 pi over 3. And positive 4 pi over 3. So really, plus or minus 2 pi over 3, plus or minus 4 pi over 3. If you wanted to show it like that. More compound. Now working backwards, write a trig equation that has the solution theta equals n pi over 3, where n is an integer. Okay, so think about how we've gone through this. So now we're given the answers. We've got to go back up to a trig equation. So what did we do in between there? We went from that unit circle to these. So go from your solutions, plot them or graph them on a unit circle, and then think about what your trig equation has to be. I just did all of that on instant feedback. I did it all on one page there. Okay, so if n is an integer, but think about it. So if n is 0, we would get 0. If n is 1, we get pi over 3. If n is 2, we get 2 pi over 3. If n is 3, we get pi. And then 4 pi over 3, 5 pi over 3, and then back. Okay, so we've got the horizontal axis, the x-axis, okay, and then we've also got these, which have a reference angle. If that's pi over 3, that means the reference angle. And these ones is pi over 3. Okay, so I'll do this, these in red. So the red, now, does it say sine or cos? Let's do sine. Maybe sine is what you would normally do. So sine of theta, when does it give me, or sorry, when sine is 0, sine of 0 is 0. Sine of pi is 0, right? So that would give me my red lines. my green lines here. So if I'm dealing with sine theta, so when sine is pi over 3, when theta is pi over 3, I get sine is root 3 over 2. Okay, that will give me this one and this one. Right, so that's green, I'll keep it green. And then, let me do purple. And this one and this one, that's going to be sine of 4 pi over 3. That's going to give me negative root 3 over 2. Okay. Now what do I do? These are opposite in sign. So if you look back at the ones where we had positives and negatives, where was it? Back here, we got positives and negatives. So that means we have the trig ratio squared. Okay, so we could show this part. So these two. That. So now we've got that and this. Remember when we're solving a quadratic equation, a polynomial equation, each factor equals 0. So that means this is a factor because it's equal to 0. This isn't equal to 0 yet. How do we make it equal to 0? Well, you can multiply by 2 both sides and bring the root 3 over, just so that there's no fractions, right? So that's the same as 2 sine squared theta equals root 3. So 2 sine squared theta minus root 3 equals 0. Now, this factor, this will be one of our factors because it's equal to 0. So our final factored form.
No, it's not.
What do you mean it's not?
You just said that sine theta is pi root 3 over 2. So sine squared theta can also not be, definitely not be root 3 over 2.
3 over 4.
Yeah.
Pardon?
Look what you wrote down.
Sorry. Multiplying these together to get, right, so I need to square this. Yes, thank you. Sorry. Okay, sorry. So sine squared equals this squared, so that when I take the square root of both sides, I get plus or minus root 3 over 2. I forgot to square that. Thank you. Okay, so now this will be, let's just fix that. Sine squared theta equals 3 over 4. There you go. Okay, so now those are your two factors. It doesn't say, does it say what form? It just says write a trig equation. So you can leave it like that. If you wanted to expand it out. Okay, but that's a working backwards.
Honestly, I think it looks really nice as 4 sine theta is equal to 3 sine theta.
Or yeah, you can have this on one side, that on the other. The thing, that's it, let's just talk about that form. Just if you do show it like this, or say you're given something like this, don't divide by sine theta. You'll miss a solution. Okay? Just like back in Math 10, if we gave you 3x minus 2 equals 4, 3x minus 2, no, it won't be that. It would be,
Yeah, that can't happen.
yeah, it can happen. Say x, 3x minus 2. Okay, if you divide out by 3x minus 2, all that you'll get will be x equals 1. And you're going to miss the solution. Okay? So try not to divide by a variable. In this case, the variable is with sign. So try not to divide by that. Now, saying that, with these, if you take a look back on the previous page, most of them were dealing with sine and cos. There were a couple where, let's go back to the first one, 2c, where it was a reciprocal trig ratio, cotan. We didn't state any restrictions, okay? When would we have restrictions? When cotan is undefined. When is cotan undefined? When sine is 0. Okay, so take a look at this. Is sine equals 0? Any angles here give you a sine of 0? No. Okay, so it turns out for most of these that you're going to do, the restrictions are not going to come into play. But doesn't mean you shouldn't check them. Basically, likely something might come into play is if when you have more than one trig ratio basically in it, and maybe you have to show, maybe you have a sine, maybe you have a tan, so you have to show it in terms of sine and cos. And that will happen, I think we've got the case in solving the identities in a couple of days, using identities, so that you'll have more than one trig ratio and it might end up coming into play. So I didn't state restrictions here. Doesn't mean you shouldn't. We will, by the end of this unit, be stating restrictions on each. I just didn't do it in this part. Okay? So,